In this video, we concentrate on the skill of finding Cartesian equations of parametric equations with trigonometric functions such as 11 part 2 in the standard graph tutorial. When the parametric equations involve trigonometric functions such as secant theta and tangent theta, we recall that in secondary school we have learned the trigonometric identity sin squared theta plus cos squared theta equals to 1, which when we divide throughout by cos squared theta, we get tangent squared theta plus 1 equals to secant squared theta. So from this identity 1, we can substitute our secant theta in this manner. From the parametric equation, we see that secant theta is x over negative 2 and tangent theta equals to y. So when we substitute secant theta and tangent theta into our identity, we find that we have y squared plus 1 equals to x over negative 2 squared. So x squared over 2 squared minus y squared equals to 1. This will seems to be the Cartesian equation if we ignore the range of the parametric equation given over here. But we know that in the truth is we can't ignore the range of the parameter given. From our understanding of standard graph, we know that this particular equation, in general, it refers to the graph, a hyperbola graph, knowing that the value of the value below this x here is 2, it tells us that over here should be negative 2 and this should be 2, because the value below the x term here is, it tells us that these distances are 2. So based on this, we get sort of the graph for this rule. But then again, we have to be careful that we are restricting the parameter value for our parametric equations. Over here, we see that theta is between negative power 2 and 0. Now, recall in secondary school you learned that theta equals to 0 and theta equals to pi will be at the extreme two ends of the horizontal axis. And when we consider the rotating angle up, this part will be theta equals to power 2 when we rotate upward. But if we talk about negative power 2, it will be rotating downward by negative power 2. So it's actually over here. So when we say theta is between negative power 2 to 0, it's actually describing the fourth quadrant, and recall our CAST in secondary school. This reminds us that in the particular quadrant over here, as described by the parametric value of theta, the range of theta, we know that only cosine is positive. So when only cosine is positive, we need to look at our x and y accordingly. Now we see that x being negative 2 secant theta is actually negative 2 over cosine theta. Now, since cosine theta is positive in the fourth quadrant, and x is negative 2 over cos theta, means x must be less than 0. Whereas for y is equals to tangent theta. And in the fourth quadrant, tangent theta is negative as well. So That's for the fourth quadrant. Tangent theta is negative. So we get the S, we see that S and Y coordinates are both supposed to be negative. This tells us that the required graph should not be the full graph. It should be only this particular portion over here in the third quadrant when both S and Y coordinates are negative. So if you concentrate on this green portion of the graph, it tells us the actual graph for the parametric equation as well as the Cartesian equation of the graph with the correct asymptote. So when we quote the Cartesian equation, we should be quoting it as x squared over 2 squared minus y squared equals to 1, specifying the range of values of x and y as x less than or equals to -2 and y less than or equals to 0. Thank you.